Hi, Brian.
Hey, Ty. I I think the meeting's still in well, hey Boone. I think the
Hi,
meeting's
Moon.
still in 30 minutes, still in 30 minutes, and I just saw the group notification, which is why I joined. I
hmm
don't know why it's broken.
So it started in a half an hour, the meeting?
It starts in half an hour, yeah.
I see. Okay.
Yeah, so
Okay.
I'm gonna stay on the call, but I'm just gonna mute and put my headphones aside.
Okay. Okay. Bye bye for now.
See you in a bit. Hey, everybody. Um, let's just give everybody a minute or two to join here. I don't think Kelly is joining. I think she said last week that she wouldn't be on. But if Rom joins or whoever, we'll let's give them another minute. All right, let's go ahead and get started. So I made a quick slide on talking about the current scope slash agenda. We talked about this a little last time. Do I have that slide? Yeah, yeah. These are kind of the stuff we talked about last time. Um, so right, okay. So I talked to Jeff McGuire from Ventana. Uh, he is talking to his legal and trying to get some permission to release a document. And so they have not I'm not 100% sure what they're doing here, but they're talking about possibly donating something. My expectation it is their mapping of LLPs to raw, um, probably how they specify byte order and stuff like that, which we can kind of depending on how much detail they give us and how much we want to take, right? We can do our own due diligence on verifying that versus our existing spec and the UCIe spec. So in light of that, I'd like to hold off any discussion on specifically on any kind of raw mapping. Um, Not that the mapping itself is hard, it's just the conventions we want to wrap around that. How we speak byte order or whether there's any other complications in timing and things like that. Um, the but they obviously don't have anything for the FLIT format. So I did do a little work this week looking at the 256 byte FLIT and what we would do for a mapping like that. And so I can talk about that a little bit. Um, the other things that we have kind of
So,
generally on the
Ryan,
agenda. Yes.
hi, I'm I'm back.
Hi, it's I.
I heard, but I heard a few minutes. So, from your check, your investigation, looks
Mhm.
like it is easy to align with UCIe
So
from.
I yeah, say for raw, it should be very easy. It's just really
Mhm,
about how we specify some things in a way that are not adding additional complications on any controller that would need to be managing these things on the UCIe side. So making sure that we respect their byte orders and things like that. On the 256 byte, it has some additional considerations, and I'm going to talk about those in a minute.
okay.
Because I think it's depending, well, it can either be like really easy or it can be, you know, moderately easy.
I-
I
I-
don't think any of this stuff is very complicated because what we've already done all of the hard work, I would say.
I see. Is it okay to ask for a short explanation of the RAW if it's not too
Of sorry, of what?
the RAW? What do you mean by RAW? I'm
Oh,
not
the
if you can
raw.
shortly for me if it's
Sorry,
not if it's okay with
I
other.
mean the raw interface for the streaming format. Uh, yeah. Hold on a
uh,
second. Let me see if I can share a
I don't
UCIe
want
spec.
to stall the discussion only if it's okay with you and the other
Yeah.
participants.
So the other things I was going to
Mm,
say that we're going to need discussion on is just document issues because the document
mhm,
has. I was going through the TIA transaction link layer spec, and it has lots of fix me's in there, which I
mhm,
didn't realize we released with that many, but apparently there were quite a few. So that
mhm.
is somewhat embarrassing. Not that I wasn't the editor on it, so I guess that's
Okay,
on David. But but anyway. Yeah, let me see if I can pull up the UCIe spec, and I can show you real quick
okay,
about the streaming formats that we're talking about here.
okay,
Here it is. Okay, so let me. Okay, yeah, I don't. This is just a version I had on my hard drive. I'm not sure it's this. None of this stuff has changed except for maybe a small errata and stuff. But
okay.
I don't know if this is necessarily the most current version. Anyway, so there's two types of connections that we're talking about here. Let me see. How do I get to? The first one is the streaming protocol, right?
Mhm,
And the streaming protocol is basically a much reduced feature set in terms of what's being required from the protocol layer.
mhm,
It's basically just handling the transport of bits across the link. There is, and you're basically just given the raw format, from does it give it basically it's just yes, it's just 64 bytes, right? This is the
okay.
wires you see on the interface effectively, right? That you're putting
Uh,
packets into. Uh,
so it's not the XI or something like that, just the data coming out or
yes, yes.
okay.
And like I said, there is inferences about the data transfer order because technically, you're transmitting 64 bytes. The wire interface you see on both sides may be a different width, which adds additional complications to the how we specify these things. So we need to be
Mm-hmm.
careful in how we determine things like Indianness and the like. But yeah, you're just putting data in, you get data out. We have we've already encapsulated our LLPs into 512 bits, right? And so we just
Mm-hmm.
map multiple LLPs to this and call it a day, right? We just have to make sure we map it correctly.
Okay.
Um, and
And the
so,
interface, and do you have a data valid on the interface or
well, there's no wires specified, I don't think.
okay.
That's implementation specific, I want to say. We're just talking about packet formats.
Okay. I see.
Actually, it's been a while since I've read this spec. I'll need to go double check, but I don't think it actually gives you wires. But yes, normally you would see wires of some specific width with some sort of valid or something like that. These are all
Mm-hmm.
credited interfaces, but you have to load them in. So yeah, some sort of valid or whatever, and then you or some sort of valid, and then you'll load them in, but you're transmitting them in this format, 64 bytes at
Okay.
a time.
Okay.
And so the streaming interface is really easy. There's no error correction or something like that on these, but we already do error correction at both. It's kind of spread between the transaction and the link layer for us. And so, which
Mm-hmm.
is something I'll talk about in a minute as well. But there's none of that in the raw format, or the streaming protocol, quote unquote, right? So,
Okay.
so there's no duplication of functions from that perspective, right? Um, there is I guess there is some argument that our LLP headers had some redundant information, but it's a small cost. Um,
Okay.
but if you look on, but there's a whole bunch of other formats, right? For a whole bunch of different protocols. Some are CXL oriented, some are PCIe oriented, et cetera, et cetera, et cetera. There was one. So the argument here for potentially picking another one was that ARM has released a specification for Chai C2C, and
Mm-hmm.
so there may be implementations in the market that have controllers focused on this, and people may want to mux our our link layer with Chai C2C implementations, right? So
Okay.
like for
Yes.
instance, if you already have an existing implementation in the market, it's already got Chai C2C, you'd like to add a couple more virtual wires or whatever the case is, another AXI stream bus or whatever on top of this. So maybe people want to mux it with this. And so that was the rationale I described last week. And
Okay.
so I'd like to at least discuss using this, what's it called? 256 byte latency optimized mode with optional bytes, which I think it's format 5 from the spec. Um, yeah, here we go. Yeah, it has two different versions. Oh no, it's format 6. Let's see, optimized. It's without the optional bytes, it's format 5. With the optional bytes, it's format 6. So we were talking about specifically format 6.
Okay.
Um, and so let's see, where did it go? Yes, for streaming protocol. So it's basically for streaming protocol, right? And
Mm-hmm.
so this is what it looks like. And so basically you get 256 bytes, and then there are 6 bytes that are carved out of it, right? Which complicates our solution in that, we can't, since we're using 512-bit LOPs, we can't just throw them in there, right? Otherwise, you end up with quite a bit of inefficiency.
Because of the header that they require, that's
Right.
okay.
Because it's 2 bytes of header and
Mm-hmm.
then 4 bytes of CRC that they do, which is
Okay.
also
Yes.
redundant for us. But I think we as we discussed last time, I don't think we want to do major surgery here. So hold
Okay.
on, I did some Excel spreadsheeting. Hold on 1 second. Where did my apologize? I had to find the window in my list here. Does it pop up if I do this? There it is. Okay. So, all right. So this is our current LLP format, right? It's 512 bits. The first 32 bits is a header. Okay.
Mm-hmm.
And then you end up with 15 32-bit granules. Um, in the in Chai C2C, the way they solve some of these issues is they actually they have like a much smaller granule size. I think it's like 20 bits or something like that. Um, and so that's how they handle squeezing into that, dealing with the header mismatches and stuff like that. For us, I looked at our LLP format, and
Sorry, again, what are they doing in the Chai C2C?
they're not using 32-bit granules, they're using 20-bit granules.
Okay,
And so they're a little more, it's a little more fine grained, and so a little they can work around those 6 bytes that are reserved in the system, and then just add a couple more.
I see.
So I thought about it a little while, and we're not really a whole lot over on, if you were trying to pack them in. So I looked a little more into the LLP header itself, and half of our header is actually just reserved space right now.
Okay,
So my thought is well, what if we redefine the LLP itself for this use case? And so, and then again, here's that's so, oh, sorry, here's the diagram for try C2C. It's, it's this same format. This was rotated 90 degrees, but in addition to the UCIe headers that you can see in these dark gray boxes, they added their
mm-hmm.
protocol headers kind of like that.
Okay,
And so I thought about, okay, so what if we did something like what Chai C2C did, but not touching the transaction layer, only touching the link layer? And so I think this is, again, this is just be a proposal. We could do something like this, where what you're looking at here is the yellow. This is the same 256 byte flit format. The yellow blocks were the 2 bytes in the beginning
mm-hmm.
that are the UCIe header. The um, pink, the purple, the pink boxes, pink, purple, those 126, 127, 254, 255 bytes. These are byte counts. Those
Mm.
would be the normal UCIe CRC bits. And then
So it's CLC for the previous line or for the previous 2 lines?
I assume it's the
The,
previous 2 lines, but I haven't looked at that in a while. So yeah, it's something like that.
okay,
And then and instead of having, and just basically redefine the LLP, where instead of having a 32-bit header, it has a 16-bit header instead. And basically, removing the reserved bits, and then otherwise treat the LLP just like normal. And so the LLP would have the LLP start bits, which are basically, so these green boxes here, it's just 16 bits that are defining whether it's an idle packet or not, and whether which which granule starts the TLP header, which granule has the TLP header in it, because there's 15 granules in an LLP packet, and so basically it is there's basically just defining which one of
okay,
those. It's a bit field for determining which one of those LLP headers. I'm not sure why it's a bit field. It's just really seems a little inefficient, but I haven't talked to David about it. But I assume that was just from a made it easy, right? So
okay,
rather why we're using 16 bits rather than 4, but whatever. And so just to keep the implementation the same, basically just preserve that part of the header. And then if we need reserve bits in the future, right, there's still 16 bits that we can keep reserved, but all of the LLPs that you're packing into this format use the same, use this kind of shared reserved bits, which are these blue bits down here.
okay.
So yeah, so I think that would be
Mm.
my proposal. Like I said, I need to reread a bunch of these specs too. I just haven't had a chance to go to reread these things, which is why I don't have a full list of the fix me's and
A-
stuff. But I
And
think
why
that would work.
why you have the reserved? Is it just because in order to have to save some reserved, or it's you needed it for some reason?
Well, there's nothing to fill those bytes anyway. So right now in our
Oh, I see.
LLP, we
So
have
I
16
see.
bits. We have 16 bits of reserved and 16 bits of header. It's a 32-bit header with half of it reserved. So I imagine in the future you're going to want some reserved either way. But specifically for this, we're not using those bytes, right? Because you
I
need,
see.
yeah,
Because you have 250, you have a location for 256 bytes.
right.
That's what you're saying, and you don't
So
need these two
yes,
extra bytes.
yes, it's two,
I
the
see.
whole the flip packet is 256 bytes, right? The
Hmm.
header is sorry, the UCIe header plus CRC is 6 bytes. So that's 250 bytes. And then the LLP packet with the reduced header size would be 62 bytes each. So you have 4 of those. So that would be 248 bytes out of the 250 byte payload that you're allowed to have.
Okay, I
So
see.
you end up with 2 bytes as reserved. And so either way, we end up with something you would just fill.
Hmm. Okay.
And I think that's that, I don't, I mean, of the potential waste you could have here, that's much better than the alternative. Because
Yes.
the alternative we had here, if we don't want to modify the LOP at all, is you only get 3 LLPs in here, or you get like three LPs and then half an LLP, which
No,
per,
so it's better to have two reserved bytes. I agree.
well, it's better to have 2 reserve bytes. And
Hmm.
I think I think modifying the LP definition for this case makes a lot of sense too.
Okay.
All right. I guess
Hmm.
does anybody have any other comments about? I'm not sure anybody here is necessarily implementing this or planning to implement this right off the gate. So maybe it's a moot discussion for people, given this is probably the second choice in terms of formats compared to raw streaming, since it is less efficient and redundant. Um, oh, that reminds me. Um, I didn't talk about a part. All right, so I am cutting something off here that is important, and I wanted to talk about that real quick too. So okay, so this LOP format here is you do end up with a big chunk of reserved, but part of the other piece of this is a check bits in the front. So there's a header check, 6 bits of header check, right? It's like 6 bits of header check, and then yeah, 16 bits of the TLP start, and then whatever's left is the reserved. So we are cutting off header check, but the all header check is basically CRC for the header, effectively, right? Or it's ECC for the header. So that comes back over to here in that you end up all of the orange bits in the diagram here end up still having the same ECC protection they had before. And then the green bits would not have ECC protection. But the UCIe standard for this particular format requires us to have CRC bits anyway. So the green bits would then be protected with CRC rather than ECC. So there, I think, and based on the standard, you
Which ECC is it?
it's a
One.
it's a special ECC.
Yeah, but is it? It has how do you call it? Is it? Can you also fix? The ECC is also capable of suggest fixing the data. So
Yes. Yes. It's
one
single.
fix, two single.
Yeah, single error correction, double error detection. It's like that.
Okay.
And it's like a modified. Actually, I can't remember all the terms. It's in this. It's in our specification. Like all of our muxing tables and stuff are in the
Mm-hmm.
or muxing tables. The what do you call the matrix that you multiply the bit field by is in the specification. So modify shao code or something like that.
And CRC is I don't remember. CRC is capable of suggestion enabling a fix or just
No, no, it's just error detection only. And so the way that
so it's
UCIe works is that you if for these flip formats, you have the sender has to generate CRC in the formats that have CRC. The
so what the
receiver you can define through configuration and how it responds to CRC. Sometimes it'll do you can request it do a resend, right? You know, if the CRC
mhm.
fails, or you can record, or there's other potential responses that you can
Okay.
define, I think.
So, okay, so but what I want to say that in your suggestion, then to replace the ECC with the CRC, then you eliminate you eliminate the offer for a fix in case of one mistake, which have a lot of um, which has a benefit because if you have a mistake in a CRC, you need to resend it or something like that. You can't fix it.
Yep.
Yeah,
Yep.
so,
If you end up with an error in the header, then you have to do a
so
resend.
so that's the so this is the 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 paid the disadvantage advantage of replacing the ECC with the CLC.
Right. So I mean, we potentially can do something with those reserved bits if we wanted to, but
Mm-hmm.
um, I'm depending on how people
The
do.
question is if someone will, for me it's okay, but the question if someone will see it as will say, okay, now it's this, you are have you are it's a problem that you don't offer the ECC, then you reduce the
Somebody
effectiveness
might
of
have
the.
that. Somebody might say that's an issue. I think the
Mhm,
um, if you're doing a UCIe implementation, let's talk about who the customer is here, right? So our original the whole point of this is to match with this ARM ecosystem that's using Chai C2C, right?
yes.
They don't have any ECC. All they have is CRC. So
Mhm,
this would be in from a you know this is actually more error correction than they would normally get in that
mhm,
implementation.
okay.
So it's still potentially a
So
better fit
I see.
in if
So
that's the target market.
so my suggestion is to offer this, but tackle it in advance. So to say, okay, we replace the ECC in a CLC, and then we don't have the option for a fix, but we think it's okay because because what you just said.
Right. Yeah. It's
That's my suggestion to add. So to tackle this claim in advance.
sure. Sure. Yeah. We can mention that in the spec as a note saying, hey, this is just kind of goes back to what they already have. I think if I had my druthers here, or if we wanted to be optimally efficient, we would
Mhm,
also redefine the TLP format. But I think that's in order to if you're gonna match their parity with them, you would revisit the TLP format, remove our ECC bits and all sorts of stuff like that, and repack that without ECC and potentially squeeze some more data in. But I think that that's probably more than what we want to do in terms of accommodating this particular flip format. But this is kind of a happy medium, I think, between the two.
okay.
You also run into the problem where even if we did put ECC, let's say we define another ECC schema and we use these reserved bits in order to do the ECC on these headers.
Yes.
And and then and we moved forward that, you still run into the same problem though, in that the UCIe is still required to do CRC, and there is still there's a header up here, which is also, I believe, covered by the CRC, that is not covered by ECC, right? So if even in that case, if you get an error, you still have to do the whole retry scenario, right? Because you don't know if that error is in those first 2 bytes, which you can't recover from, right? So
Okay.
I don't think it adds, us not having ECC on our LLP headers doesn't add any efficiency to the system, because you potentially still have to respond to CRC errors because of the UCIe header.
Okay.
Okay. Any other comments on that, people? Oh, I think we lost Paul. Okay, so I think that's all pretty direct there. I'd like to quickly talk about the spec itself, and then maybe we can end early. I think there's a lot of fix me's that I need to quantify. Where did my spec go? Oh, here it is. Well, all right, let's just talk about the structure real quick. So right now we have we have 2 chapters, there's not 2 chapters, there's like 11, but the 2 ones that are primary here are the transaction layer, which has most of the transaction layer, but not all the transaction layer. And then we have a link layer section, though we do mix some things in terms of, that, are possibly candidates for reorganization, but those are the 2 primary things. And then we basically talk about the physical aspects, everything else. And then I'll be mapping on another chapter here for the control path. But I don't know whether the UCIe mappings are going to be an appendix or another chapter. For the fix me's, there are a whole bunch of them throughout the document. Oh no, it's actually less than I thought. It's like 7 or 8. So I think I'm gonna, for future meetings, I'm gonna go ahead and break these out as topics that we can talk about. These are definitions that just never got filled in.
Mm-hmm.
So maybe we can just break that out as something to discuss as well. So yeah, so these are things I'm not sure whether we want to do these. I might revisit these before we do the appendix, because we might want to cover these fix me's in the update that we have for the control path, because that'll probably be published first.
Okay.
Yeah. So I think that's all I have for this week. Do you guys have anything else you'd like to bring up?
Brian, a question. How do there is activity in the file layer also group? the group
Okay.
led by Elad.
Hmm.
So how do you maintain, that the link layer and the file layer are aligned? Because they are defining new stuff. And is there, I think there it should be some mechanism to, or a meeting to make sure that both groups are aligned. Or is there something like that,
I don't
or
know.
you
No,
just
no,
trust
it's just,
them to tell you if they did some change?
yeah, we just assume somebody has in the best interest to communicate that stuff to us. I don't have time to go to the FI meetings. I'm not even sure I'm going to have time to do all to do all the edits here for this spec. So
Mm-hmm.
yeah, we don't have a particular person or anything like that, and it's definitely not. I'm definitely not proactive on it.
Okay, so but do you think it's an issue, or you think that no, it's
I
okay?
mean, the
I'm
primary thing
asking
that
because I'm asking because I'm joining the system work stream, and from the system perspective, of course, everything should work together, and we take it for granted that the file and link layer are aligned, and that's my question:
yeah.
is there is it does it do you think that we need to do like a meeting to you with the link layer team and the file team to see that they are aligned, or some what is your opinion here, if you understand my
I
question?
mean, yeah, I know what you mean. I I mean, it makes sense. I honestly am not necessarily the best expert on how that gets mapped. Like again, I wasn't the editor on this spec, right?
Mm-hmm,
David was. And so like a lot of the complications of the mapping. So the mapping itself is not a big deal, right? Because we're really just defining a packet, right?
mm-hmm,
And then the complications end up with, what are your assumptions on how that packet's transmitted and what bytes received first and things like that. But
mm-hmm,
and so we've made some assumptions in this specification that are pretty clearly laid out, right? Whether, I believe it's something like, each byte is mapped to, what's being transmitted, or we do on a granular basis. I can't remember on individual lanes and things like that, right? So it basically has implications about which gets across the link first and things. But at the end of the day, I don't remember all those conversations, and I definitely wasn't the author on those. So I'm really don't know what could be changing in the file layer that would break those assumptions.
so you
Um,
think okay, so first from what I see that you are now the expert on the link layer. That's from joining the talks,
as it
that's my assumption. I don't know that you
Yeah,
are at
I
the
mean,
moment the
I
expert.
was here when it was being written, and I
Okay.
helped David with some specific things. Um, I wrote the more, so my expertise is probably more on the protocol side, right? What's called the transaction layer here, right?
Okay.
The bus mappings to the transaction layer. I wrote a lot of the quote unquote bus variants, which are,
Mm-hmm.
choosing, bus fields and stuff like that, and how we map those to packets, and how do we, what's the best trade-off for making those efficient. So that was my primary contribution to the specification. All the stuff at the physical layer is like, I kind of understand, some of the rationales there, but I wasn't the author, and I'm definitely not my day job is at the top level, right? I'm an SSC architect. So all of
Mm-hmm.
the microarchitecture that's in the file layer, and how that actually gets across the link.
Mm-hmm.
While again was there for the discussions in some part, I don't have a lot of
So
stake in that in that implementation.
okay, so do you can you point out the section in this spec in which, let's
It's
say,
just
okay,
it's the
when
back half, right? So you talk about you know um, so the things that would be implemented. So okay, all right. LLP transfer order, right?
mm-hmm,
So if we're making changes to the file layer, right?
Mm-hmm.
This from this will get affected. All of the discussion about training and RX and stuff like that, the link physical interface portions, all of this stuff can potentially be updated.
So chapter 8. So
So
you say
just 8 down.
8 and 9, or 8, or just, or
Um, so I think error handling is mostly at the transaction side.
mm-hmm.
Reset. I mean, these are link state stuff. Some of these link state stuff are all very fuzzy from the PHY perspective.
Mm-hmm.
I don't know. Like, I think, again, I think, 8 and higher, I would want people to take a look at, basically. Though I think error handling is probably the exception, and because that's all kind of mostly at the transaction layer, and
Mm-hmm.
but everything else below that, I think 8, 9, 11, 12.
11, 12.
I
Okay.
would probably want some, people from the file layer to talk about if they have changes that they're
So,
doing, or if there's new file layers we need to accommodate. And
okay.
and the way that UCIe and other standards handle this is they make it a lot more a much cleaner partitioning, right?
Mm-hmm.
In terms of chapters and interfaces and stuff like that between these things, we mix things a little bit more in this because
Okay.
I think we wanted
And you
specifically to
made,
allow more implementation
okay.
flexibility.
Okay. And from your point of view, I'm asking the question in a reverse order. So, and you, are there any recent changes in those chapters that, we should tell the PHY team about it?
This document has not been updated since publication at all.
Okay.
Like, nobody's like we basically we released it. David moved on to other things, and then nobody has even looked at this document since
They,
that happened.
again, David, who I'm not
David
familiar.
Kruckmeyer from Ventana. He was the editor. He was the author and editor of this specification.
Hmm. And he's still in the OCP.
Yeah, he just doesn't have time for this anymore. That's where he was on some of the previous meetings I think we talked about,
Mhm.
but he doesn't have time right now for this. And so
Okay.
Jeff McGuire from Ventana is trying to get some of the other documentation that his team authored, David's team authored.
Mhm.
So for the mapping to UCIe. So I think that'll probably be their contribution. And Jeff might come on and talk about some things, but I talked to David about, if whether he could review, and he said he probably will be able to review, but we write to make sure that it meshes with what he says. But
Mhm.
the
So you said the document haven't, so, but now, okay, but now the document that you are writing in the last month is not this document, is the,
it
it's,
is technically it is a chapter that will be integrated into this document, but has not been integrated.
okay.
It's a standalone document right now. It's called the control path spec, and so it'll turn into a chapter in this document. It just hasn't happened yet.
Okay, I see, I see. Okay, so you are just, okay, so you are writing or changing the control path, and I see.
Yeah, it's all it 100%. Well, it talks about the main band, but it talks about the
Mhm.
main band as it talks about changing main band states and things like that. The actual all of the nitty gritty happens over the sideband, which isn't covered at all in the spec at all. So it's a
Mhm.
new link. It's a totally new link layer just for
Mhm.
sideband, and then it's
Okay.
a control protocol that layers on top of that for controlling the state of the main band.
Okay. So the control path, okay, is the control path is for the sideband, you say, right? That's
Yeah, yes, it is it's two, actually, I'll just show it to you. Hold on a second.
But okay, but you gave a simple answer. So if the document hasn't changed, was never changed, then there is not less to worry about. Just
Yeah.
just
There's nothing to communicate to the PHI group at this time. So
okay.
yeah,
The
so
question
just real quick, so the
if they have stuff to communicate to the link layer team, that's an open question.
yes.
Okay.
So the control path spec is broken into two parts. There is a sideband protocol, right? Which
Mm-hmm.
is basically just a memory mapped bus memory mapped transaction packet format for communicating over the sideband, right? And then there's a link control protocol, which is it defines a very limited set of registers on either side of the sideband that can be
Mm-hmm.
used for communicating link control, main band link control and link state. And so and then we define all these messages that are there. Basically setting test patterns and things like that.
Okay. When you say memory mapped, you mean the it gives an option to write into a register on the other side of the link, right? That's what.
Yes. The transaction is a combination of address plus data plus transaction type.
To just write to the other side of the link, something.
That's what
Right?
sideband protocol does.
Yeah.
So
Okay.
sideband protocol, the side UCIe sideband is very wait, where it is? I have the wire diagram here somewhere. There it is. Yeah. So bow sideband in
Mm-hmm.
this in the bow PHI spec has no protocol on it, right? It's literally just you know uh, transmit data, a clock, and a frame signal, right?
Okay.
And so, but there's a timing diagram. There's no information on how you use that in any way, shape, or form.
Okay.
And so we tell you what the actual protocol is for the signaling. We talk about um, the the packet format that you use for transmitting a transaction across that link, a memory map transaction again, and you have there's all this protocol definitions on reads and writes, and here's the different operations you can do with that packet, right? And then we
Mm-hmm.
also define an ECC schema for those packets. So
Mm-hmm.
that's what the sideband protocol does. But both of these things are optional. Like if you don't want to use, if you want to replace this with your own sideband protocol, then you can do that and then just use the link control protocol. The link control protocol is just a set of registers on top that utilize another transport layer, whether that be the BAO sideband protocol or it be like I2C or whatever the case may be, but it's just registers that you define to change the main band state and things like that.
And this is also an option from one side of the link to write to register on the other side of the link. And it can, and as you said, it can, from your perspective, it can either be either other interfaces.
Yeah, you
Yeah.
can there's two things here. The transport layer, which is the BAO sideband protocol, and that can be replaced with whatever you want, and the link control protocol, which controls the actual interface state. Those are just a bunch of registers. And so
Okay. And here
you
there
can
are
use whatever link you want.
and the register here are defined, right?
Yes. Yeah,
Okay.
there's just a handful of registers. Where are they at? Yeah, here we go. So there's basically the minimum here is just two registers. There's a partner message register and a link state register.
Okay.
And that's the whole specification is those two registers. And then we have a whole bunch of instructions that you can send to that register that set different PHI states and things like that.
I see.
But like I said, these I haven't figured out exactly how I'm going to do it because the documents really aren't compatible from a from multiple levels at the moment. So it's going to take me a while to figure out how to move these chapters over to the other document. So, but for logistics reasons, because apparently like releasing a new spec under OCE is requires a lot more signatures. Just updating the link protocol spec is easier. So, the transaction link layer spec is much easier. So we're just going to update that spec with these bits.
I see. Okay. Another question.
Sure.
Does the data path has a fixed set of registers?
There's no registers. Well, there's no defined registers, I think, in the transaction link layer spec at all.
Okay.
So if you need some for control or whatever. So I guess that was something else I was going to suggest. So different standards handle this differently. But if so as an example, like UCIe, right? They basically defined a MCTP packet format for dealing with chiplet manageability and stuff like that, right? And they defined kind of specialized packets for transmitting that either over the UCIe sideband or over the UCIe main band. You can do either one of them, right? And they kind of have these exceptions in the specification for, so that the system can easily differentiate these packets and stuff. I'm not sure whether we need anything quite so grandiose. If it seems a very heavy-handed way of dealing with this, because their use cases in UCIe were like, these like arrays of chiplets where you might have 100 chiplets in a die, and you want to communicate these messages and forward, the multicast packets across the system for turning specific bits on and dealing with cascading security requirements and having hardware enforced security inside in the routing layers and very complicated requirements. I think what you were saying a minute ago about registers, I think you could define sets of registers for all sorts of features in that space, whether it be manageability or discoverability or other system stuff, and just and use these same conventions that we're using like in the sideband interface.
The reason I'm asking is because if you want to, again, part of the system work group was the requirements to enable like a common drive software layer.
Yeah.
So for that, if you want to have a commonality, then you need to, for the lower layer, to define a set of like a minimum set of registers that control the transaction layer. That's what I think, that in order to standardize the software, you need some.
I mean, I don't think the transaction layer needs to necessarily be controlled. So obviously the phi layer has to have a level of control kind of in flight, right? Because the phi changes state. The transaction layer and the link layer for that for that matter, for the most part, are dumb pipes. And so you're looking at like, you're assuming some wires from one side of the chip are getting to the other side of the chip, somewhat error-free, right? And so that's the whole goal of both the transaction link layer, right? There's not a whole lot of management on at that kind of top level that isn't built into the wires themselves.
So you say there is no need for registers? It's not like
not for the not for the transaction layer. No, I would
for
say
me.
if you need registers and stuff, it would be even at an even higher layer than that. And what I'm thinking of, what I'm talking about, like this manageability stuff, would be so I guess you have two problems here, right? Like we talked about this whole SOC disaggregation thing, where you have
Mm-hmm.
like a subsystem and you've made a cut, right? And you'd like to move that subsystem to a chiplet, okay? And I
Yes,
think
right.
what we have here for the transaction link layer solves most of those problems, right? But you're solving the problem of I have this chiplet now, and I need to move this to another SOC, right? And then
Uh,
your
Not sure I'm
problems.
getting you. Again, can you? I'm not sure I get your.
So, like I
Repeat.
said, our problem was we have a subsystem, right?
Yes.
It already has a predefined perimeter, right?
Mm-hmm.
Has a certain number of wires. We already know what we want to do with the subsystem, right?
Yeah.
And so the goal of the transaction link layer when we were building it was I want to be able to make a cut. I want to draw a perimeter around my subsystem,
Mm-hmm.
move my subsystem to another SOC, and be able to communicate, do basically all the same things I was doing before, right?
Okay.
And
Okay.
so
Got you.
we can handle that. But from what I understood about your systems team, is that, for the open chiplet economy, you want to be able to take that chiplet and potentially migrate it to another SoC, right? That doesn't have
No,
those same wires, right?
not necessarily. From what I think is that the idea is to ensure the multi-vendor chiplets. So which is now, from what I know of the market, there is no example of a company which is doing it, connecting two chiplets from different vendors to each other. So that's
Yeah.
the main goal of the system. So
Yeah,
the
yeah. So
system, okay.
that's what I'm talking about, right? So you're taking a
So
chiplet
why?
that wasn't
Yeah.
from an SoC and you're taking it, trying to integrate it into a new SoC, right?
Not a new, you want to connect it to a different chiplet, which may have the system side of the SoC. That's
Sure.
what you,
Yeah. I think we're saying the
okay,
same thing.
okay.
So my point is that you have to agree at a bus level, right? So,
Mm-hmm.
if one side has an AXI and AXI stream and then n number of interrupts or whatever the case may be, both sides have to agree on that, right? So that's one part of your problem, right?
Mm-hmm.
And so you can do that by just adding some language on top of the specs we have, saying, okay, I want these options selected. If both sides agree to it, then you're compatible from a wire perspective. But there are a variety of things that aren't covered when you say that, like all of the system level management things. So the things I'm thinking
What do you
about would
mean
be
from a wire perspective? You mean from the PHY perspective? When you say
from a
when
but
from,
from well the phi is the phi, right? We already have a standard for that, right? The
so what do you mean
transaction
then?
link layers. So let's talk about it in terms of perimeter, right? So let's assume that we're compatible from a phi perspective, right? You guys pick the same lanes, we're doing the same protocol, we're both pick the same
Yeah, okay,
version of
okay.
bow, right? The
I thought that,
transaction link layer
okay.
moves that perimeter outwards, right? So it moves it from the phi to the bus, right?
Mm-hmm. Yes,
So you're at the AXI level, right? So
yes.
you can now get one AXI signals from one side to the other, right?
I, I don't have to move to change one. I don't care if the other side has an AXI or, for
You
example, an AHB.
well you should.
I don't want to. I don't. I don't think I need to know about it. I just need to know that I can transfer data from one side to another.
Yeah,
If
but that's not what we've specified.
okay,
That is not what we specified. So you do
okay,
actually, it is an AXI encapsulated packet that goes from one system to the other one.
okay.
So if you want to just be completely blind to it, right? You can go with something like PCIe or CXL or something like that. But we don't cover those standards right now, right? Like we're at a lower level, right?
Okay.
So right now we do at a bus standard. So you do care. Now you can do a bridge. You can go from AXI to tile link or whatever you want on the other side, or you can treat it like a generic data
Oh,
message packet,
oh,
right? It can be, and
okay.
it can be, you can have some sort of, you can have some sort of generic data message that's encapsulated in an AXI packet, right? Or you can define your own message packet and use one of the other bus protocols that we have. That's fine. But
Okay.
either
So
way, at some point when when you decode that packet from our standards point of view, you are assuming some sort of bus mapping.
okay. So I gave a wrong. I don't. Okay. I made a mistake with my example. Okay. So XI to XI on both sides. You say
Okay, so that's what the
that's
spec does.
mandatory. Okay. So you expect to have one XI to on both sides. All right.
Well, yeah, or another protocol. It just has to be defined, right? It just
Okay.
you have to define what the protocol is, right? And that the transaction link layer gives you a bunch of options for that.
Okay. So the most common one is the XI, right? Or
I would
let's
expect so. Yes, most
okay.
people would pick AXI or Chai.
Okay, so
So,
let's talk about AXI. Okay, let's assume both sides selects AXI.
uh-huh.
Okay, so so
But
and both
that's only part of your solution though, right? They only gives you memory mapped data transport, right?
yes.
So then, well, I guess what I'm trying to drive at here is that, you know, our transaction link layer gives you that flexibility, so long as you add a little bit of definition on top of it, that you can get bus transactions from one chiplet to the other one. What it doesn't standardize or solve is all the other systems issues that you have on top of that, right? Like there's a multiple ways that you can transport a interrupt across this link, but we don't say you have to transport interrupts in a specific way, right? Like they can be virtual wires, or they can be MSIs, or they can be AXI stream packets like
O- o-
ARMS,
Okay,
TLBs,
now I
and things like
understand.
that.
Okay, okay. Now I understand when you say wire, what you okay. Now I understand what you mean when you say wires. For example, an interrupt.
Right.
So
Yes.
the
So
XI is
an interrupt can be
the
a bunch of
XI
different.
connection is solved because it's standardized, and okay, we understand that both sides should be able to you should be able to do a memory mapped transaction over the XI. That's okay, but you say there can't be other signals like interrupt which are
Well,
not defined.
there can be actually. So we have things called virtual wires
Hmm.
in the specification too. So technically, as one potential solution, is you could tie an interrupt to a virtual wire, and there's a limited number of
Okay.
virtual wires and things like that. But we don't say that's what they're for interrupts, right? You have to still specify, okay, this controller has in interrupts, and this is how you handle interrupts, right? You can also do them as MSIs where they are interrupts get turned into AXI transactions, and, you know, and then they're actually written
Yeah.
to memory addresses. That's what RISC-V does, you know, and
Okay.
so,
But this is a
but
good
that's
solution. Okay, so that's a great solution. Okay, the
it
how
is
do you
a
call it? The
solution, but it's a system dependent solution, right? So from a standards point of view, if you're trying to move this chiplet from one vendor to another vendor, right, you have to have those assumptions and you have to know them, because both sides have to, like the guy that's going to be consuming that triplet has to be able to design his SOC knowing these things in advance, right? And so from a standards point of view, you have to like say things like interrupts, things like power control, possibly things like firmware download, things like temperature control, you know, temperature readout, lots of things like that that would end up being controlled from a firmware perspective or potentially by hardware, the hardware state machines. All of these like system level things that we normally do in either system controllers or in fixed logic in terms of you know, clocking managers or temperature managers or whatever the case may be, those kinds of things need to be also transported across this link in a way that the different vendors can plug into that API. And it's not necessarily a software API, right? It may be an actual, you know, hardware perimeter in some cases. So all of
yes,
those
but it
individual
is
things need to be probably discussed from a system level.
Okay, okay, now I understand. So the link, okay, so what you're saying is that the link layer gives the all the support to define the higher level on top of the link layer.
Exactly.
So it gives the first, it gives the AXI to transfer data. Second, it gives the virtual wires to transfer any kind of interrupt or other stuff. And I guess it also gives like a generic registers that you can write from one side to another.
Like, yeah,
The,
it's memory mapped. It doesn't actually define any registers. So you would actually have to define, if you want specific registers for communicating things like MSIs and stuff like that, you'd have to define the registers at a higher level too.
Okay, but it's a memory map, so it's easy. It's okay, so
Yeah.
we can do it.
Well,
Okay.
there's multiple buses that you have the option of, right? Because we have this thing called bus protocol variants. So there are, I don't know, half a dozen different types of buses you can transport across that link. Some of them are memory mapped and some of them are just raw data streams. Depends on
Okay.
what you pick. But you would have to say, from a system level, you'd have to define, okay, we call them profiles, right? A profile is a set of buses and a set of assumptions for the transaction layer in order to map one chiplet to another, right? And a profile may have multiple bus protocol variants in it. So it might have chai plus AXI stream, things like that, right? And so you'd have to, if in order to have for two chiplets to talk, you'd have to define a protocol or use not protocol, I'm sorry. You have to define a profile or use an existing profile because there's an existing profile in the spec, I believe. I need to go double
In the
check.
link layer at the
Yeah,
moment,
in
in
the
the
link
new.
layer. I think
Okay.
it's chai plus AXI light. I think is like kind of the default like the default profile because that's the one Ventana was using in their chiplets. And so use AXI light for register writes, and then you use chai for the main data transaction.
Okay.
I think the mastering is in different ways. I can't
So,
remember.
okay.
But the point is like you'd have to define those bus protocols that go into the profile, right? And then from a system level, all those other things that I talked about, you'd have to define on top of that as well.
I see. Okay, so I learned a lot from what you explained now. Okay, so thanks. But
No problem.
but it wasn't my original question. Although I actually, yeah, I understand a lot now. So thanks. But my original question was when I asked about registers is on the link layer. My question is, does the link layer, in order for it to work, just to configure it and enable it to work, does it need like a set of known registers or configuration?
No,
Not,
no,
not
no. It's fixed. It's not dynamic. It's just fixed.
it's okay. So you're
I
saying
mean,
there is
an
no need, there is no
implementation
need.
might have a register, but it would be for things that are not covered in the specification. So things like communicating errors, right? Like if you have a link error, like we define what the errors are and error responses, but we don't define how it's communicated to the host system, right? So for instance, like a link controller might have an interrupt and an error status register. It might have performance tuning or quality of service registers or something like that, but we don't define those. And honestly, I don't see any value to defining those because those will be things that'll be managed at an SOC level that don't need to be communicated across the link. And so unless you're really trying to lock down what a controller looks like, across multiple vendors and making them very portable, I don't see a lot of value in defining that either.
Yeah, okay, so yeah, that's okay. So so this was my intention to for such registers like arrow handling. So you don't
Define them
think?
if you can define them if you want. I just don't see the value necessarily because only because like it's all localized on your side of the link, right? So you're going to design an SOC. It's going to have a link controller, right? You're going to write a driver for that link controller. I
Yes,
don't need to necessarily move that driver to another chiplet. That chiplet's going to have its own driver, right?
no. So
You just
no,
need to
No, that's so from as I see it, and I think that's the maybe I'm wrong, but I think that's the idea of also of the system work group is that you can write okay, you can also do a reuse of the driver. So you can offer such like a library of drivers, and you'll have a same driver for the both ends of the link layer. So you don't have to rewrite the driver at each time.
Okay. I
That's
mean, I
that's
get
my
that's fine. And so you'd have to go survey some people that are doing individual link controllers and see what they need. I don't I have very limited experience in what
mhm,
those look like. I think again, most of my focus is making sure the chiplets can talk to each other and making
mhm,
sure that if they talk to each other, can they do all the same things that they would normally be able to do, um, you know, if they were integrated into a unified SoC, right? And so the other things talked about in terms of like power management and temperature management and um, interrupts and yada yada, all those
mhm,
things need to be managed in a way that is easy to communicate and deal with. Um, things like a unified driver on both sides of the link are um, not concerns I've concerned myself with because there's so many other harder and more and higher priority problems.
mhm,
But yes, you would need registers for those things that I mentioned if you were trying to do an actual like unified open source driver. And you would actually you need to specify other things as well too, I'm sure. There's probably a bunch of stuff that I'm not even thinking of if you wanted to get a fully unified driver that works across multiple implementations. You'd also need to talk to a bunch of people that are doing these things. Like we don't so my company doesn't technically have an implementation of this. We have
mhm.
other similar things, but we're not. We'll probably eventually make one of these, but we haven't done it yet. And so I
Okay,
actually don't know other transaction link layer registers you might need. So you'd probably need to talk to somebody like Ventana or see if anybody's actually writing another one because they're the only one I know of that has actually written this spec. Blue Cheetah has their own
what you mean a
variant of
link layer?
this. Yeah, the link layer.
But I
Blue
think that
Cheetah has their own.
Synopsys and Cadence have a link layer, but UCIe link layer.
Yeah, it's not a bow link layer.
I see. Okay.
I mean,
So it's a
unless our mapping to UCIe here works out real well, and they're motivated to make one because that they like our way of other bus mapping here, but they have their own way of mapping AXI to AXI stream, right? I
mhm,
haven't even read. I intentionally have not read their spec on how they do that, right? But they
yeah.
have
Okay.
their own spec on that.
So you say no. Okay. So you say that only Ventana and Blue Cheetah developed a link layer for the
Yeah,
bow link
I
layer.
think Ventana has a version that they made, and then I think there's a commercial version of basically the same thing being managed by Blue Cheetah. And they've
Mm-hmm,
probably diverged at this point, but something like that.
mm-hmm,
There might be other people in the market too that have done this. They just haven't come forward. I think. I mean, Rom, I talked to here that did a lot of work on the control path spec. Uh, he did an implementation of the sideband.
mm-hmm.
But I think his sideband implementation was focused on a different uh,
Ram
transaction link
from
layer.
which company?
I, I think Rom's at Meta now. He moved.
Mm-hmm.
I'm not 100% sure.
Okay. Um, okay. But basically, my plan is for my company also to develop such a link layer.
Okay,
That's
excellent.
but obviously, I think that one of the key element would be if we can develop one link layer that will support both BOW and UCIe.
Yeah, that would be the goal here.
That's why I think your effort of you suggested to align both is it's a very I think it's a very good direction.
So to be clear,
Mhm,
from UCIe's perspective,
yeah.
the terminology is different in that we're not this transaction and link layer thing that we have is actually a
Mm.
protocol layer from UCA's perspective. We're
Okay.
using their FDI, their die-to-die adapter takes over what we would call a link layer, and that we're doing the protocol layer. But
Okay.
regardless, the stack looks a little different, but it's not. It solves all of these same problems.
Okay.
All right. Well, I
Okay.
think I got to run. So
Yeah.
it was good chatting with you, Ty.
Yeah. Thanks a lot. Thanks for
Talk
your
to you later.
time.
Bye.
Okay. Bye bye.